Hello, everyone. Welcome to this lesson on best practices in 3D digital heritage. This is quite a broad topic, so I'm going to be narrowing it down somewhat to discuss the topics of documentation, sustainability, and accessibility. So in this presentation, I'm going to be covering, first of all, the uses of 3D in cultural heritage and archaeology, followed by the FAIR principles and the London Charter, talking about the principles of documentation, and then further on sustainability and access. We will also discuss the differences between metadata and paradata, and look at some examples of 3D documentation, drawing on policies and projects within the UK and the EU, and discussing some current issues before going forward with some recommendations. So to start the discussion, I would like to highlight why we use 3D documentation in archaeology. These points are outlined by the 4D Research Lab in Amsterdam, and they categorize this by representation of documentation or to visualize an idea or a hypothesis. So 3D can show the outcome of a study. It presents discoveries or illustrates an idea to a certain audience. In the way that a 2D technical drawing can convey information about a ceramic, a 3D model can also do this, but in a more interactive way. It can also be used as a tool to guide the research process. So instead of using the 3D model as the end product, they can be used as an interactive process between the researcher and the subject. So 3D modeling can be used as a tool for source interrogation and a guide for interpretive reasoning. So if you're reconstructing architecture based on historical sources. And since photogrammetry documents objects as they are in the real world, this process can also be used for careful analysis of that object. And it can also form the basis for further digital reconstruction. And finally, it can be used as vision enhancement. So it can enhance visualization of objects or landscapes, for instance, changing light to enhance certain details of an object that would otherwise be hard to see. So based on these points, we can see that 3D imaging and modeling is not only about the end product. Instead, it's an important tool for our research. So while we are keeping that in mind, we should also be remembering that each step of our workflow is important, and we should follow certain principles of good practice. So for good data management, we abide by the FAIR principles. These are the guiding principles of scientific data management. The first step is findability, meaning metadata and data should be easy for both humans and computers to find. So machine readable is essential, meaning that they have a persistent identifier and be indexed in a searchable resource. Data must also be accessible, meaning it is free and open access. Interoperability means that the data usually needs to be integrated with other data. The metadata uses a formal and applicable language for knowledge representation. And finally, reuse is the ultimate goal of FAIR. The data and metadata should be described well so that it can be replicated and or combined by others. So reproducibility is key to academic transparency. And we should remember this when we're creating our 3D works. Whereas artists who paint a portrait, for instance, don't necessarily explain their process, nor want their work to be replicated, 3D modeling for research is entirely different. Also, when we discuss ethics in another lesson, we also include the CARE principles. And this stands for collective benefit, authority to control, responsibility, and ethics. And this normally goes hand in hand with FAIR. The documentation is an important part of your 3D imaging process and how you can work towards achieving the FAIR principles. The London Charter is a set of principles outlined in 2006 for using computer-based visualization methods in cultural heritage. And it defines principles in relation to intellectual integrity, reliability, documentation, sustainability, and access. So principle 4 of the London Charter is documentation. And this ensures that the author uses comparative analysis and evaluation. It ensures that audiences can understand what the visualization aims to represent, ensures that you are publishing your research sources, and explaining the methodological rationale of the visualization. So the London Charter is quite flexible in how this can be accomplished. It can be in text as annotations on an online 3D model, but there are also many guidelines on this, which we will examine shortly. So one component of the documentation principle is your methodological rationale, which includes publishing your metadata and paradata. And in case you don't know, metadata is data that describes other data. It provides information about the 3D model, such as its format, its creation date, and file size. Paradata, on the other hand, is data that describes the process of collecting and producing your metadata. It provides information about your methods, which tools you used and why you chose them, and the procedures used to produce the data set. So it's basically a documentation of the process of collecting all of your data. And usually when we're talking about data, metadata and paradata are grouped together and described solely as metadata, because the term paradata is not universally used within scientific fields. So this is just for you to know the difference between the two in case you come across it. Now to look at some examples. 3D Icons supports the development of Europeana, which is the European Digital Library. It created guidelines for each stage of the 3D creation pipeline. So each stage is interrelated, and metadata should be running parallel to all of these stages, meaning that the metadata should be documented for each stage. So the data capture stage, methodology, licensing, all of it. And as I've said, the aim of your project should not just be the final 3D model, but also in describing what the model will be used for, determining the appropriate publishing method, and how it will abide, or how it does abide, by the FAIR principles. 3D Icons also outline specific metadata that should be attributed to 3D models. This includes describing in detail the artifact or monument being digitized and its provenance, describing the digital representation, so the format, and its online location, the technical information and methods used to ensure the accuracy of the representation, and information on access, licensing, and reuse. The amount of data or metadata will depend on the project, but at a minimum, you should be providing the who, what, when, where, and how relating to a file or a project. So it can be broken down into specific categories as outlined here by the Archaeology Data Services Guide to Good Practice, which is focused on the creation, use, and reuse of archaeological data. So at the project level, metadata is recorded very broadly for an entire project. So it would cover project dates, project details, site codes, geographic information. The resource level is documentation of all the resources used within this project. So it can be PDF documents, images, databases, GIS shapefiles, any sources used to gain information. File level is where you can get quite specific about individual files. And in the next slide, I'll cover what this can look like for a 3D model. And administrative metadata covers elements such as the creator and any alterations that was made to the data, and includes information about intellectual property rights and ownership of the data. So the file level metadata outlined by the ADS requires specific documentation about each 3D model. For example, this would include the number of vertices and triangles that make up the model, what the scale is and its projection error, the texture resolution, things like this. If the model has been created in Metashape, much of this information can be found in the documentation report that's automatically generated in PDF. However, it's very important to remember to include any information about changes that you've made to the model during post-processing in another program. If you've used any shaders or light sources. And there are also other helpful resources out there to help with your documentation of metadata, one of which is the Digital Lab Notebook produced by Cultural Heritage Imaging. So to give an example why documentation can be important, really it helps the viewer know what they're looking at when they view your work. It's quite difficult for the viewer to assess the accuracy of a 3D model. Therefore, authors must be transparent about their degrees of certainty. So any decisions that were made during digitization. At the 4D Research Lab, there is a set protocol for 3D modeling, including color coding the model to show its variability. So the certainty class labeled in blue indicates that there is 100% certainty in how that area of the model is portrayed. And usually this is because the remains were 3D scanned. On the other hand, red is labeled as a very high degree of uncertainty because it's based upon a theoretical argument that the model looks the way that it does. So this is just one example of how you can be transparent about your work. When I share a 3D model of something that has been captured in photogrammetry, and if there's an area that was not fully captured, so I had to manually reconstruct it, I'll add an annotation on to that area of the model describing the error. So there are quite a few issues that remain in this topic, some of which were outlined by Valeria Vitali in her 2016 article. First, many people enjoy using the term perfect or digital copies of artifacts, which is a statement that is not only untrue, but it's also very misleading. 3D visualizations are representations of objects. 3D modeling and even 3D imaging are based on a continuous process of decision-making and subjective interpretation of the available information. And often this information is incomplete. So to call something a copy implies complete accuracy. Every visualization is subjective, just in the way that a photograph is, since it expresses the point of view of the photographer. And we don't often think about subjectivity in 3D models. And many cultural institutions rely on their prestige to guarantee the quality and accuracy of the 3D visualization. But that reinforces the misconception that there is only one possible or correct 3D image. However, it's usually the case if two people are given the same object to image or model, there's going to be various degrees of differences between the two. That's why documenting your methods and workflows can explain why those differences appear. And a big challenge is the lack of standard in how to convey accuracy. So for example, in what format should this be done in? Should it be on the model itself through annotations, in a paper, or in a blog post, things like this. And Valeria notes that we should be encouraging the idea that a 3D visualization is the representation of only one possible hypothesis or interpretation. So to move on, two other principles in the London Charter that I would like to point out are 5 and 6, sustainability and access. These principles usually overlap and build upon the importance of documentation. Long-term sustainability of a 3D project without its proper documentation is like finding an unlabeled box of pottery sherds in a depot. Without its context, its use within our research can be quite limited, as well as its access to the public and to us as researchers. So when we talk about access, of course, we mean that the research should reach as many people as freely and openly as possible, if it is ethical to do so. And this can be done by publishing 3D models online on platforms such as Sketchfab. However, it's not enough to just upload your work to Sketchfab and that being it. we need to keep in mind that the long-term sustainability of online platforms. And we should be thinking about how to store our data that Sketchfab doesn't allow you to upload. For example, your raw image files from the data capture stage. Are you going to delete those files once you build your texture because they're taking up so much space on your hard drive? Or are you going to find a suitable data archiving service? So in the slide, I've added some examples of online digital repositories that you can upload your data to, which ensures long-term archiving and accessibility for future reuse. Each resource is free up to a certain amount of data, and there are, of course, licensing conditions for sharing your data. And platforms for archiving 3D data is a growing field, so I'm sure I will have to update this very soon. As you can imagine, there are some issues when it comes to these principles as well. In theory, it may sound fine, but in practice, it doesn't always go so smoothly. In 2019, there were investigations into the scholarship of digital heritage, and the authors did not find many reports building on or verifying previous digital heritage research. So in the way that we normally investigate and build upon archaeological research, this doesn't happen as much with 3D projects. However, when it does, it's thanks to open, free, downloadable sites such as Sketchfab and Europeana. So from their study of 264 select papers containing mention of 3D visualizations, only 3% contained explicit links to online 3D models and its related data. And 4% contained links to external video content, and 12.5% contained links to images of 3D models. However, at the time that the paper was published, none of these links worked anymore. So this is a clear case of the issues in long-term sustainability and access. And a reason for this is because institutions and researchers require funding and facilities for exhibition, digitization, and long-term archiving. They also require continual funding for new technologies or the time it takes to train staff or teach the public how to best interact with these technologies. Another problem is that the way that 3D models are published online can cause issues in accessibility. So high-resolution models can often not be viewed or downloaded without access to a high-quality computer. And many 3D authors don't optimize their models for web or mobile viewing. So when models are in fact optimized, the original data is not also made accessible and therefore doesn't follow the FAIR principles. There are also various ethical implications that will be touched on in another lesson, but they include digitizing culturally sensitive material, data sovereignty, and intellectual property rights. And these can, and oftentimes should, in their own way, limit access to 3D work. So just some points to keep in mind going forward. You should be thinking about what the purpose of your digitization project is and how you're going to be implementing the FAIR principles. Are you documenting all levels of the applicable metadata? Where are you archiving and publishing your data, and how long is this infrastructure going to be supported? What is your budget, and is there enough room for the project design, implementation, dissemination, and archiving? What level of access will users have? And finally, always keep your raw data. And Valeria Vitelli sums it up well in her article. She says that with most of the informative value hidden, 3D visualizations are as useless in academia as would be a paper missing the author's names, methodological discourse, bibliography, and footnotes. So with the mention of bibliography, here are my sources for this lesson. All right, thank you.